All right. Chapter 1, Lesson 5, Variables and Expressions. Let's go. So we're going to start out with different sentences and expressions. So these would be a mathematical expression and a mathematical sentence. So write an expression for the phrase, Emilio is 7 years older than his sister Rebecca. Well, let's look at this from Rebecca's point of view. So if I know Rebecca's age, I'm going to add 7 years. So Rebecca would be x plus 7. So using x for Rebecca. So if Rebecca is x years old, what expression, so a mathematical expression, it represents Emilio's age. Suppose Emilio is 19 years old. We can write, you can now write a mathematical expression that shows the two expressions are equal. So in words, Emilio is 19, and we also said that Rebecca is x plus 7. So if I put those together, take that x plus 7 and put it here, x plus 7, this is Rebecca and Emilio. So the question is, now what two expressions are equal? Now expressions have no equal signs, sentences do. So x plus 7 would be one expression and 19 would be the other, and they're connected into a sentence by the equal sign. So if Emilio is 19, how old is Rebecca? Well, so many of us have siblings that are how many years older than us. So, if Emilio is 19, 7 years difference, minus 7 would make a Rebecca 12. So equations are mathematical sentences that contain the equal sign. So this equal sign is important. That's what changes it from just an expression to a sentence. So equations are what we're going to work with for most of the rest of our mathematical lives. That equal sign is very important. Some examples of that would be like this. An open sentence is an equation that contains a variable. Now, a variable can be x, it could be a, it could be just whatever letter you want it to be, s. It depends on what you're using it for, speed or rate, or, it just depends. When a variable in an open sentence is replaced with a number, you can then determine whether a sentence is true or false. So take what we did a little bit ago. If we replaced x with 11, we would put 11 plus 7, it goes to 18. That is not equal to 19, so therefore when x is 11, this mathematical sentence is false. But if we went over here, we replace x with 12. Sorry, that's a little odd looking. Replace with 12. 12 plus 7 is 19. That checks out, so this would be a true statement. A couple more vocabularies for us. The solution is a value for the variable that makes an equation true. Solving the equation is the process of finding that solution. All right, example 1. Find the solution for 44 plus p equals 19. Is it 11, 9, or 7? So they want us to substitute in 11, 9, or 7 for the letter p. So we're going to replace p with each value. And we're going to put it into a chart here. So for value for p is going to be 11, which makes 44 plus 11 comes out to, that looks like 55. So 55 is not equal to 53, so therefore it is false. Let's put in 9. 9 plus 44 comes out to 53, so that comes out as true. Just for fun, let's make sure. Let's put in 7, comes out to 51. That is not equal, so therefore that one's false. So my answer would be, the only solution that worked was 9. So your turn. Pause this one, give it a shot. Okay, so I would put this into a chart, or I can just kind of write them out here, which is what I'm going to do over here on the side. So 24 minus 11, 24 minus 13, and 24 minus, I hate it when it does that, 15. Okay, and we want it to, does it equal 9? 24 minus 11 comes out to 13, so that is not a solution. 24 minus 13 comes out to 11. We're getting closer. 24 minus 15 would equal 9. So it looks like my answer is going to be 9. Or sorry, my answer is going to be 15. Remember, I like a check mark on all my solutions. All right, example 2, multiple choice. You're going to see a lot of multiple choice in this class. All my tests are going to be multiple choice, pretty much. Which value is a solution of 4x minus 1 equals 11? Well, the easiest way to do this is going to be to insert each one of these in 4x. So the solution is the value that makes the equation true. So that's what we're looking for, is the solution. What makes this true? So how we're going to solve it? Test each value. So first we're going to substitute in 5 for x. 4, substitute in, replace x with 5. 5 times, or yeah, they skipped a couple steps there. 4 times 5 is 20. Minus 1 equals 19. That is not equal to 11. So that's not it. Let's try choice B. Substituting in 4 for x. So replace x with 4. This is going to come out to 16 minus 1. Comes out to 15. That is not correct. So it's not the answer B. Try C. Replace x with 3. This comes out to 12 minus 1. That comes out to 11. That's the correct answer. Just for fun, just to make sure, put in 2. Comes out to 8 minus 1 equals 7. That's not correct. So there is only one option. Since the only one that is true is C, then that means the answer is C. All right, try this one on your own. Okay, well, we just start substituting in. So let's go 6 plus 1. Or 6 times 1. 3 plus 6 comes out to 9. That's not going to be right. Let's go 6 times 2. That comes out to 12. 3 plus 12, that does equal 15. Just to make sure, 18 plus 3, that's too high. That would be 3 times that. 4 times this would be 24 plus 3, also going to end up being bigger than 15. So the only answer that it can be is the letter B. All right, so they want us to try this mentally. So what you think here is, what number times 7 is 56? Well, we have to go back to our times tables, and we go 7 times 8 is 56. So therefore, my answer for x is going to be 8. The solution is going to be 8. And we'd probably just punch it into our calculators. Okay, try this one mentally. Again, so now we got to think, what number minus 15 is 40? So we also could go 55 minus 15 equals 40, or we could actually think the opposite of that. What number is 15 more than 40, if that helps for you? Kind of your choice. X equals 15, solution is 55. Okay, pause these, give them a shot. All right, so for letter A, we gotta think, what number divided by 3 equals 7? So what number divided by 3? So if I multiplied 7 by 3, that would come out to 21. So my answer is going to be 21. So 21 divided by 3. And that would come out to 7 equals 7. Over here, h, or 6 plus h. What number plus 6 equals 19? So we take 13. 6 plus 3 is 9. What you got? 19? Yep. 6 plus 3, we go to 19 equals 19. All right, so there are a couple of properties we need to know. So just properties of equality. So we have the symmetric and transitive. We won't see symmetric quite as often, but we will see transitive quite a bit. So symmetric is if one quantity equals the second quantity, then the second quantity also equals the first. So basically, I can flip everything around the equal sign. So if A equals B, B also equals A. If I have a problem like this, 10 equals 4 plus 6, I can switch them. So these two can switch. 4 plus 6 equals 10. Moving on. So if transitive property of equality, if one quantity equals the second quantity and the second quantity equals the third quantity, then the first equals the third. So how that would look if for with just letters and symbols, if A equals B and B equals C, then A equals C. I call this the middleman. You take out the middleman when you have this. So A equals B and then B equals C. I can actually just cut out the middleman and say A equals C. So that's what this is saying. So 3 plus 5 equals 8. 8 equals 2 times 4. So I can just cut out the 8s and say 3 plus 5 equals 2 times 4. And if I solve both of those, it's going to come out to 8 equals 8. All right, so let's use these properties in a statement here. So name the property of equality that is shown by the statement. So z plus 6 equals 8. 8 plus 2 plus 8 equals 2 plus 6. Then z plus 6 equals 2 plus 6. Okay, so we look over here and we're like, is there something that they both have in common? Oh, they have the 8. So this is the middleman one, so that would be transitive. Yeah, say A plus B, B plus C, cut out the middleman, A equals C. All right, state the property of equality shown by each statement. Go. All right, look at this one here. So you have x minus 9 equals 8. 8 plus 8 is 7 minus 19. Therefore, x minus 9 equals 17 minus 9. Okay, this looks like another one. Cut out the middleman because they both have 8, so that's going to be transitive property of equality. Let's look at this other one here. 12 equals 3x, so it's 24, and then 24. Looks like all we did here was switch the two when we went over here. So that would be the symmetric property of equality. Okay, the quotient of a number is 4 and 9. Find that number. Okay, this is going to be the majority of our things here. So the quotient of a number and 4 is 9. Find the number. So we start that out in words here. Quotient of a number and 4 is 9. So we can say a number would be a place value and 4. So let n be that number. So now we know what the variable is. So the quotient of a number of 4 and is 9. Remember, is an equal. So it looks like the quotient would be division. So it would be n over 4. I might actually see in your homework, you might do this, which would also be okay. I prefer it to be like the book does because you're going to see this more often. You'll rarely see this year. Is, as we said earlier, is an equal sign 9. So we can write that out as your final solution here. N over 4 equals 9. Now we have to figure out how to solve that because it said earlier here, then find that number. So we're not done. So we have to figure out what number times here. So think, what number divided by 4 is 9? So 36 divided by 4 would be 9. So n equals 36. Solution for the entire problem is going to be 36. All right, try this one on your own. All right, the sum of a number and 7 is 12. Find that number. Whoops, they just gave it to us there. So the sum of a number, number, we're going to call it n. I'm going to do that over here, n. The sum is going to be a positive, so it's going to be plus, is 12. So something equals 12. So the sum of a number and 7, so n plus 7, is 12. So what number plus 7 equals 12 would be 5 plus 7 equals 12. I can check. That comes out to 12 equals 12. So my answer is going to be 5.